My name is Tsahi Levent-Levi. I'm the author of Blog Geek Me. I write about WebRTC most of the time. And I'm here to talk about the Codec Wars. So when Eleanor came to me and said, well, can you come to a TechTok? I said, fine. She said, on what subject? I didn't really know. And then I remembered that I think that the codec issues with WebRTC are not done yet. That was about a month ago, I think, correct? And I said, okay, let's do something about codecs, VP9 starting, going to be in Chrome. That's a good time to write about it. So we said yes, we had a title, we had a description for this. I even went on and wrote the whole presentation about a week ago, and then I need to rewrite it again. And the first question is, well, we've got WebRTC. We had the Codec Wars, if it's going to be VP8, H.264, which one of them is going to be the mandatory video codec. And so there was a decision. So is there a codec war at all at this point in time? Okay, or are we done yet? And the simple answer is no, we're not. If this will work. No, we're not. We still have a problem. It's still the same problem. And the problem is, what codec should I place in my WebRTC implementation? There is no good answer for that. And let's start from the beginning. And the first question is what should be the mandatory codec when we're talking about WebRTC? And we'll start from looking at the video part, because that's where most of the wars are today. And the first answer to that was, well, it's going to be VP8, right? Google decided to implement it, so it's there in Chrome, you can use it, it's working, everybody's using only that, because that's what was available for the first 2 or 3 years of existence of WebRTC. Good enough. Okay, if it's not broken, why fix it? But then people came and said, well, it should be H.264. Why? Because everybody else uses H.264. If you're using a mobile phone, there is an H.264 codec in hardware acceleration on the phone already, so why not use it? Set-top boxes, H.264. You want to buy a codec from someone, go buy VP8. Okay, anybody tried? No way. If you want to do something with H.264, you can find hundreds of companies doing something with H.264, including the implementation of the codec. So you've got two codecs, VP8, H.264. H.264, everybody knows. A whole ecosystem around that. VP8, well, Google, so that's nice, but nobody else. But then you go and check and say, well, there's one minor, tiny detail. VP8 is royalty-free. You don't really need to pay for using it. There are no patents involved. So that's a non-issue. Okay, so you can use a codec freely, and WebRTC is free in almost every other way, so it makes sense that it would also use a free codec. So that was a good choice. But then we have H.264 again. And if you're doing something with mobile, and you want to use video, using H.264 works better, because you're not hitting the CPU, you're working on the hardware acceleration of the same device. So you're eating less CPU, the phone doesn't heat as much as it does when you try to encode or decode VP8. Okay? And the battery life is longer, whatever that means. So why not H.264? And then Cisco comes and pulls out a rabbit, says, well, we've got Open H.264. That's our implementation. It's open source, and we paid MPEG-LA for all of the patent royalties involved. So why not use that? So we had this question in front of us. Which one? VP8 or H.264? And the decision, as usually happens with standardization bodies, was not to decide at all. They said, well, let's have both. VP8 and H.264. Everybody can say why this is a stupid decision to make?
It's twice as much work for everybody. Nobody's happy.
Yes, now, TokBox should be happy. Twice as much work for everybody means more people coming to TokBox to buy something because, well, somebody else need to take care of all the headaches. And it's not going to be anyone else, it's going to be us, okay? As a company that provides tools, you want as much complexity as you, okay? It makes sense. But what exactly do I need to do? Do I need to support both? Who needs to support both? Can I choose this one or that one? What happens if the same system runs part of the service with this codec and the other part with this codec? And I need to now do a multi-party call or whatever. So it becomes, headaches. But you don't need to worry. It gets a lot worse than that. And the first thing that we need to do is to say, well, what happens today with the browsers? What's the current situation? We have Google, and now we're starting to add also audio, but we'll look at that in a second. And Google has VP8 implemented. There is VP9 somewhere as well, which is, next generation of VP8, but it's under a compilation flag, and it works or doesn't work, and we're waiting for that to complete. And then there is H.264 that now they need to implement because both VP8 and H.264 needs to be there. And also because Google already stated, unofficially or officially, however you want to call it, that they are going to support H.264. If you go and check for, I think in Discuss WebRTC or either the Chromium bug list, Justin Uberti already stated that H.264 they plan to implement using OpenH.264 by the end of this year. Then there's Mozilla, the VP8 and H.264, just because they decided to take money from Cisco and not only Microsoft, not only Google, sorry. They needed another source for their money. Cisco seemed a nice company to get money from, so that's an alternative. You have Microsoft, probably H.264, just because they have patents there, and that's how Skype works and Link works, so why should they invest in anything else other than this for the first version? Also remember that Microsoft doesn't have support for WebRTC yet. They started having that with the new Edge browser, okay, but it's a work in progress. And if I'm managing the development of that thing, I wouldn't want to place more risk than I need to. And if this is priority for me, and it probably is, because of the assets that I already have, then this is the first thing I would implement. They haven't stated yet that this is what they're going to do, but they didn't say anything about VP8 either. Then we have Apple. They have nothing with WebRTC, but if you look at what they use today, H.264 and H.265 for their FaceTime service. So they're on this branch of the video codecs. Ericsson, why they're even here, that's a big question. Probably because what they have is the open WebRTC stack, which is an implementation of WebRTC not coming from Google. So we have a second independent implementation that is open sourced. They have both VP8 and H.264. If we look on the audio side, all those that support WebRTC have G711 and Opus. Microsoft will probably add G722 just because they like it. And Apple use AAC LD wherever it is that they are using it. So it seems like the audio part is quite done, but the video part is a real mess. So let's talk about the video part. And the thing is that VP8 and H.264 are interesting, but they really aren't, because they are old technology. If you look from today, let's say 4 or 5 years into the future, they're not going to be good codecs, at least not in what you assume you can get. And if you look at video codecs, the first question is, how exactly do you measure them? What's the best way to decide if a video codec is good or bad? So the first one would be to say, well, it's the bitrate, which means if I take a video and I compress it with an expectation to get a certain quality out of it after I compress it, okay, how much bits am I going to get from that compression? So the older codecs use more bits, the newer codecs use less bits, which means that I can get either better quality for the same bitrate that I have, okay, or I can reduce bitrate for the quality that I need and use less bandwidth on the network. Both good things. So what I would like to achieve is a codec that has as low bitrate as possible. Now the rub here is that if I want to go there, I need to pay, and the payment is complexity. The more I need to invest in compression, to get better compression, the more time or CPU I need to invest in order to get there. And this is why we need hardware acceleration for codecs. Because this CPU time is not going to happen just because I have a better ARM processor. It's going to happen because I'm going to use acceleration to do the same thing. I'm going to use brute force. Codecs usually work with brute force and with heuristics to get to what it is they need to get. You've got this, let's say 1080p resolution or 4K resolution. That's a whole lot of pixels to look at, and you need to do that 30 or 60 times per second. In order to do that well, you compress it with hardware. Okay, so we have this problem. I need to make sure that the bitrate goes as low as possible, but I need to make sure that the CPUs and technologies that I have in hardware and software are capable of doing that in reasonable time, which is real time. But is it the only measurements that I have today for codecs? Are there other ways in which I can measure what a codec means to decide what codec I need to pick up? And the answer is, well, it's harder than that. I need to look at error resilience. We're going to send that data over a network, and that network, as good as it is going to have packet losses, latency issues, jitter issues, whatever. In order to overcome these issues, I need to do a lot of things. But are these things built into the codec itself, or do I need to build it on top of the codec? Does the codec offer these mechanisms to me? H.264, at least the baseline version, is very sensitive to packet loss, for example. The smallest packet loss that you have on H.264 kills the video immediately. Then there's this minor issue we talked about, patents. Do I need to pay patents? How much is it going to cost me, these patents, for this specific codec? It might look weird, but up until I think a year or two ago, it was obvious that if you want to use a video codec, you pay for the patents. Up until 5 years ago, if you wanted to use an audio codec, you knew that you were going to pay for the patents. It was obvious. Nobody makes a codec without getting money for the patents on that codec. That's how the whole industry were working up until today. And then there's the issue of hardware acceleration availability. Why H.264 eventually went into the standard of WebRTC and not only VP8? Well, there is no hardware acceleration for VP8, or almost no hardware acceleration available. And H.264, almost every chipset today supports H.264 hardware acceleration. So if we are going to invest in adding a codec, we would like to assume that we will have this available as well. Now we have two families of codecs to speak about. The H.264, H.265 line of codecs, which is the patented part, but with a large ecosystem. And we've got the VP8, VP9 line of codecs, which is mostly Google, but not only. And if we look at H.265, several interesting things happened in the past few months. I think it was on February or March, the MPEG-LA came out and said, well, we've got this large number of patents. These are the companies that are going to get paid. Okay, and we're going to take 20 cents per unit. If you're going to use our encoder or decoder, this is what you're going to pay us. And that's it. So, that's MPEG-LA. This is how they worked with H.264. The cap on the royalties, which means the amount of royalties that you are going to pay until you stop paying for a specific year, was a lot higher than that of H.264. But, that's fine. New codec, new technology, makes sense. Now, I've marked in red the interesting companies. Just remember them. We've got here Apple and Samsung and KT and NTT Docomo, Orange, SK Telecom. The others are boring companies. And then a month ago, a new group comes along. Okay, a new alliance of companies which calls itself HEVC Advanced. HEVC is the high efficiency video codec. It's the other name they give to H.265. And they say, well, we've got these guys, and we also have patents on H.265. And if you are going to use H.265, you need to pay us as well. And we're going to charge you, well, different amounts for different types of devices, but if it's a mobile implementation, that's 80 cents per device. And oh, we're going to ask for 0.5% of all the gross revenue that you're going to make from the content. Okay, so if you are providing content using H.265, you're going to pay as well. Doesn't matter if you encode or decode, just by streaming it to someone, you need to pay them as well. And that's a real issue. Why is it a real issue? There was a small company called Netflix. Anyone knows them? So Netflix at CES this year, January, came out and said, well, we're going to use H.265 to stream 4K videos. See, if you want the best resolution of videos, we're going to stream it to your live. No other cable company can do that, but we do it over the internet, and that's going to be using H.265 because H.264 is just too much bandwidth. Nobody's going to be able to even get that in time to decode it. So you need H.265 for that. Now, the problem with Netflix is that it isn't Orange or NTT Docomo or AT&T or Comcast. They actually have low margins on the money they make. And if you have these low margins and someone comes and tells you, well, we're going to take this amount from your gross revenue, it doesn't make sense anymore. Okay, so this kills a lot of business models around the ability to use this codec at all. Think YouTube. YouTube makes no money, or at least not from its stream. So how can they pay these amounts of money? It makes no sense. And this opened up the opportunity. And the opportunity was, well, we have a new battle over the next video codec. Up until now, this is what you had, H.261. Next generation was H.263. Then H.264 is the next generation, which we're currently in this generation. And the next one was supposed to be H.265. So the first obvious contender was H.265. It's a standard. It's available. A lot of companies started supporting it. Telepresence systems already have this stupid codec inside. Okay? But now VP9 actually looks interesting. Same complexity, so it gets to the same kind of bit rates. You need to, at the cost of similar CPU, it's already running on YouTube. So a lot of streams going from YouTube to laptops today go using VP9. Why? Because it takes less bit rate. So Google needs to pay less for the actual streaming part. They stream less bits, and you get better videos out of it. And they've been running it for about a year now. And it's working. So it makes sense. Large deployments already exist. A lot of TV manufacturers at the same CES announced that they support VP9 decoding inside their smart TVs. So hardware acceleration is already there for the decoding part, at least. Okay, so that's like, an obvious alternative. Especially now when someone came and said, well, this is going to cost you a ton of money. Question? And then there's Dala. Okay, Mozilla decided that if Google has a codec, they need a codec of their own. So they have Dala. And then 3 weeks ago, I think it was, Cisco came out and said, we have a codec, let's call it Thor. My logo, by the way, they didn't. I don't know why companies come out with a new codec and don't put a logo for it.
Because you're doing Thor.
Okay, so we've got this question. And in that great slide that I did at the time, I said, well, on the horizon, we've got the next codec, and Google is already working on what they call VP10. And again, they forgot to make a logo. So I had to do my own. Now, the problem is this. This is what I did last week. I spent a lot of time on the animation, how it pops up, everything. Okay? But then the next day, the following day after I finished this presentation, the announcement came out, and the announcement was about the Alliance for Open Media. Everybody heard about that one? Yeah. Okay, who didn't? Okay, so a bunch of companies that you probably know came out and said, well, what we want to do is build an open source codec with no royalties involved. Essentially, let's do VP9 again. But let's call it by a different name so nobody says that this is Google. So now we started here, H.264, 261, 63, 64, and we have the contender, VP8, these two, and this line of codecs is now starting. And the question is again, who is going to win this part? So my guess is that VP9 is winning because HEVC Advanced came and said, we want too much of your money. So nobody is going to do that, or nobody smart enough is going to do that. And we've got Dala and Thor, white noise. It's white noise because there is no real implementation, and those that are actually in charge of doing codecs and doing something with them are not looking at these codecs. Okay, Cisco and Mozilla are not really players in the codec space, although they would like to think of themselves as such. Google isn't either, by the way, but they have Chrome and they have YouTube, which is a lot more than these two have in assets in the codec area. And then the answer to this question is probably the Alliance for Open Media, if they can pull it off. Why? Because this one is already set. You can't stop this one and reboot and start everything from scratch. Designing a codec takes a lot of time. Then you need hardware acceleration. You need people that will implement it and then get it into products. So the Alliance for Open Media will either say, well, you know what, it's VP9 and we're done. We won. Or they need to build something, which will take more time. And that's the picture we have now. And back to the Alliance. Who are these Alliance companies? So the first obvious answer is Google is there. Don't worry. Okay, we know what they're doing. If they end up being there, it means that we're going to have a codec that will run on YouTube and will be in Chrome and will also fit WebRTC. So it makes sense. These are.
Congratulate you, Tsahi, on the logo you created for Google. It's very nice.
This is another one that I need to change. Now, try finding that on Google Images. You won't. It's not easy to, get that asset. And then there's this other company, Mozilla, right? Okay, if Google does something, they need to be there. Third one to join is Microsoft. Now, this is interesting. First of all, because we have, I'd call them the three major browser vendors here. I know I'm forgetting something, but we'll get to it. Okay, and they're all saying the same thing. We need the same codec to be there, and it's not going to be an H.264 something codec. It needs to be something that is royalty-free to run the internet. We can't do anything else. That's a huge statement to make, just because it's the three of them. Microsoft also have Skype and Skype for Business as assets. So it's not only a matter of browser and operating system, it's also they're not the largest anymore, but a large consumer voice over IP service and probably the largest unified communication service run by software today. Then there's Cisco. So those that went with H.264 and went with Thor decided that, let's band together to make something that actually works. These two means that you've got most of the enterprise businesses already involved. So anyone doing something with unified communication is probably going to align with these vendors' decision. Because you're either going to run a Cisco machine as your PBX or the Microsoft Skype for Business. One of these two. Yes, there's Avaya and Polycom and others, but these are the big names. So everyone else would align with them. Then we have Netflix. Okay, so we started with H.265 for 4K. They're, caught with their pants down, so they need to do something else. So the first thing is to join the alliance. The second thing, I don't know if that is going to happen, but it probably will. They will switch to VP9 at some point in time, from H.265 at least, for the part of streaming 4K videos, because they can't pay the money that they are being asked to pay. One more thing about Microsoft. The next day after they joined the alliance, they also stated, well, you know what? This Microsoft Edge browser, we're going to add VP9 into it. Okay, so they're going to support VP9. At the moment, it's not for WebRTC, so don't get excited. It's only for decoding videos, essentially YouTube. But this is in progress. It's in implementation already. 2, 4, 5. We're missing 2 more vendors in this alliance. Next one is Amazon. Why is Amazon there?
They stream a lot of videos.
They stream videos. Okay, the Amazon Video Service.
Compete with Netflix.
So it's there. And again, they're the low-cost vendor. Same as Netflix. They're not going to pay someone else money that they don't have. And the last, Intel. Now, Intel is interesting just because there is no name in this space. Okay, why is there no name? It's mobile. The game here is mobile. Everybody here has a phone with an Intel chip inside. Okay, it doesn't happen. So if they're here, it's going to go into laptops. We're all happy, I'm sure. But it's not going to make a dent. So yes, we have a chipset vendor here. It's, you know, a nice logo, but they're not a player in this space. So the next question is, who is missing? Yes, Apple is missing, right? That's an issue. Vertical player. Have a new iPhone 6s from today. I wouldn't worry because they never do what everyone else does anyway. The next part that is missing is ARM. Not ARM the company, but all the ARM chipset vendors. Okay, so until Samsung, which has vested interest in H.265 because they are one of the patent holders that we've seen. But until Samsung, Qualcomm, Broadcom, and a few others join and band over here and say, well, we're going to join the alliance and make sure that this new codec, whatever it's going to be supported by our chipsets with hardware acceleration. This whole thing, whole alliance is not going to make any difference anyway. Okay, so until they join, it's going to be a sad alliance. And the last one is the cable companies, or those that actually stream content and don't do it over the internet, but do it directly to the homes. Why? Because they are different and they are still very large. There are a lot of cord cutters, but at the end of the day, Comcast is making the most amount of money out of videos in the US today, probably. Yes?
You spoke of Samsung as somebody who's vested interest in the H.265 line of codecs. But then also in the alliance, you see that Cisco is present. Cisco's also made an investment by releasing over H.264. They're paying the royalties. It's not like it's...
Yes, but
they got out of that. They had
you need to look at Cisco in a very different context. I'm Cisco, okay? I look at my business. And I don't look at the router business because I'm not, the one paying wasn't the router business. It was the guy that paid $4 billion, 4.3, to buy Tandberg business. Tandberg does video conferencing and telepresence. Okay, now I've got these huge telepresence devices. Each one costs $100,000. I've got smaller units, bigger units, but I'm invested in video. I don't do the chipsets. I go buy the TI chipsets like everyone else. I shove it into my devices, build the product around it, and sell it to companies. Here you've got, what's this? A Polycom device? No, this one is it's Microsoft. No,
This is camera.
it's not just a camera. It's a Polycom device. It's a, video conferencing, logical, video conferencing device. No. Okay? But you build these kinds of products. Let's say you've got 100,000 of them deployed around the world. That's $1 billion business for you on a yearly basis. So what you're telling me now is that I cannot connect it to the browser, which is the future, just because the browser runs VP8 and all of my products run H.264? Is that something that I can live with as a company? The answer is no, I can't. So I must make sure that the investment done in the browser, in the current version of codecs, is going to support what I have. I don't want to transcode and do these things. It's too expensive as it is and too much work. So I must ensure that H.264 runs in the browser. So, I pay the $6.5 million a year for the yearly cap of MPEG-LA on H.264. That cost me $30 million, across all the years that I will need to do that. Small money for $1 billion a year business.
Right. My question is really if Cisco
Now, wait.
investment,
Wait, it comes down to H.265. I'm not a patent holder, so I'm going to pay for those patents when I start putting H.265 in these devices. Okay? Now, in the new generation of products, I've got a lot more flexibility on what I put there. Okay? I don't have legacy devices with H.265 on the market. So I can say, well, I couldn't care less about H.265. I moved to VP9 just because it's there. Okay? So it's two different decisions. They're not on the path of doing H.264 something because they have a vested interest in MPEG-LA. It's because they have legacy devices using H.264. Two different decisions for the same thing. Okay? So that's the current situation.
Hi.
Yes.
The Cisco Open H.264 implementation, does it support the same hardware acceleration that is available today for?
No, this is a lot trickier because you can't do that. So you've got the open source code, but you can't use it. You can't modify it. If you modify it, you need to start paying for the patents, MPEG-LA rules.
So why they will do
So what? Because what you end up getting is a library that is precompiled from Cisco through their CDN directly. If you change anything in that sentence that I said, you go and pay the patents on your own. So you've got the open source implementation, so you can see the code and see that it's good. Okay? Otherwise, it's a closed binary coming from my competitor called Cisco. I'm not going to use it, but now you can because you know what's inside. So you have this code, you have this binary. Now you need to download it and install it, and you need to do it on runtime. You can't do it. You can't preload it to your application and download the whole application with the library. You need to download the library from your code. Okay, so there are a lot of, let's say, small letters in what you need to do in order to make that legal statement work for you.
about the VP9 acceleration? Is anybody working on it, or the ARM
Yes.
has to support it?
Yeah, so acceleration for VP9 exists in decoders coming from Qualcomm and Samsung, as far as I know, for the latest chipsets only. 19 different TV vendors already stated that they will support hardware acceleration for VP9 decoding.
So for example, let's say if this alliance becomes successful, but then you have one of the largest players in the industry, this guy on the left side.
Mm-hmm.
He will remain, and that controls a major market share for a lot of big
But
markets like
again, think of them as we talked about Cisco. What does it mean? I'm now Apple. There's this alliance. That's a good thing that is happening. I'm going to use that, in 3 years' time. I can't join now because if I join, what the hell I'm going to do with all the billion iPhones that I've already have on the market? Okay, I can't support them at all with this new codec. It's all fresh. And I need to put new hardware acceleration. Adding hardware acceleration into a chipset takes 18 months. Okay, so we're talking iPhone 7s, okay, or iPhone 8. That's like a long time from now. So in order to be there, it takes me a lot more time, and I'm Apple. I'm not going to say anything until that happens. So even if I'm going to work on it, I'm not going to announce that or join an alliance like that.
They're probably going to watch it.
Yes, they'll watch. They'll add it into their chipset in terms of acceleration, and one day they will just,
Say,
yes,
Will Schiller.
open it up.
Yeah.
That's, who knows what they will do. Okay, but if all the world will end up going with the alliance, they will have no other choice.
Like they had no choice with Flash?
It's different. Flash was diminishing even before that.
Even before that.
Yes. You started seeing HTML5 gaining momentum, a lot of things of how we're going to throw Flash by using HTML5. When they threw Flash, it took a lot of time until today where you see other companies throwing it away slowly.
Yeah.
It's
They
different.
Used to do that.
It's different. Okay? But it will take time. And it takes time because it's not software. When it comes to hardware, it takes a lot more time. Okay, I worked at a video conferencing company before, and we looked at that with, well, there's a new codec coming out, no problem, 3 years. Why? It's 18 months until TI will get us the codec. Then we need 18 more months to actually put it in our hardware and build the software on top of it, and we've got a version to ship. Okay, so that's like the timeline we start speaking when you need to do things in hardware. And there is no spec for this new codec yet. So the beginning of the timeline isn't even known. Okay, I went and asked. I said, well, interesting, we have an alliance. I found the person in Google in charge of it, and I asked, okay, so this is like VP10. You're going to take VP10 and copy paste to the alliance, or is it going to be VP9 copy paste to the alliance? He said, I am clueless. I don't know. We just announced it, but we didn't really have any official meeting yet to decide what to do. Okay, so even saying this is VP10 and not VP9 is more an assumption on my side than what they announced that they are going to do.
But as you pointed out, if one believes in the alliance, then it puts a bit more credibility on VP9.
Yes.
In the way that Microsoft said, okay, we don't know where this will go to, it'll be
Yes.
something new, but VP9 is now a stepping stone as opposed to just a random Google thing.
Because of two things, and not only the alliance. One of them is that the mind shift from doing patent-based codecs to the fact that codecs need to be patent-free in order to succeed in the world. You cannot patent a codec in 2015. That would be my first statement. Okay, if you look at the alliance is half developers, half lawyers. The lawyers are there to make sure that no patent gets into the, okay? That's how it works. Look at the announcement coming out from Cisco about Thor. It's like, we've built the best team of developers that know everything about codecs, and we put a bunch of lawyers to check that we're not having any legal issues with MPEG-LA. It's actually written there. So this is how you need to build and design codecs today. Otherwise, nobody will adopt it.
That was Jonathan Rosenberg's blog.
Yes.
It's well worth reading. It's fun.
Yes.
He calls them patent trolls.
They are patent trolls.
And you should go back to 13 at the moment, because one of the questions is, who the hell are these guys? And when is somebody going to talk some sense into them?
So they are not trolls. Most of them have actual businesses.
Yeah, they're TV companies, for God's sake.
GE, Techno.
It's a bunch of TV companies saying, who are all these people streaming not to the TV?
Well, you've got video, which actually does video conferencing stuff. You have universities here, a lot of companies in Japan and Korea. Look, you've got KT, SK Telecom, and then SK Planet, and I don't know, a bunch of companies.
I think one of the problems with that is this device. If you were buying an enterprise hardware, probably it would still work in that space. But if you are building a $50 phone, and if that phone has to carry that kind of royalty.
No, there are two other problems. The first one is there is no enterprise hardware anymore. It's an oxymoron. Nobody's building enterprise hardware. And then that's nice. At the end of the day, that's an ARM chipset in a box. It's the same device that you have on your phone, but low power. That's it. Okay, so it's the same chipset, same software, same everything. There are no designed systems anymore. It's everything commodity hardware. And the business models have changed. You no longer pay for session, and you no longer pay for port. The assumption in the world today, a lot because of Skype, is that, well,
Free.
yes, voice and video calls are free. You don't expect to pay for them. You need to pay for something else, which means that the business model is going to be asymmetric in nature. And with an asymmetric business model, you can't pay per device or per software that gets installed. It doesn't work for the business model. Okay?
So while
Yes.
on the slide, I'm all for the Rebel Alliance, but the Empire Strikes Back model is that ultimately MPEG-LA and all those companies convince HTTC Advanced that they're morons and that they're destroying their market. So the possible comeback is,
Now-
because there's no benefit to these guys, of these 5 companies dicking around like this.
Here's the problem. Let's say they do that, and they succeed. Let's see where we were. Oh, this slide.
Yeah, the horse is a little way out of the barn.
So you've got these small companies ruling the web, and you've got these two small companies along with Google that stream most of the video. So I'd say, well, if Facebook joins, end game for internet video at that moment in time, okay, all of the internet video is actually going to be alliance video.
Yep.
Okay, cable companies are important, but would they want to pay that money? Probably not. Chipset vendors would start adding decoders for the alliance video because these guys are here. Okay, so you'll have now two ecosystems. Both of them will have chipset acceleration in there, already working and running, but it doesn't really matter anymore. And also look at who are the companies in the IETF that makes the most noise or have the most credibility. These guys, not the other ones. So what gets into the standards and what needs to be supported are going to be the open codec. Okay? So now, one last thing. Where is the audio? We never talked about audio up until now. And I'm not going to invest a lot of time in that, just to say that what we have today is only one thing, and that's Opus. Great codec with one minor problem. There is no hardware acceleration for it. And no one is investing in hardware acceleration for it. Not only that, there was no real progress in the codec itself or its implementations in the past year. So all of the investment, mindshare, focus, whatever, went to video. Why? Because audio is solved. But this is not the case. And the thing is that someone needs to ask what's next for the audio part. Because there will be something next. It's only a matter of time until that happens. But the fact that we don't have acceleration for Opus is really bad.
It's very complicated. This takes lots of CPU.
Yes.
And we are using it. So.
Yes, yes.
And we are using the Google. I forgot the name now. We dropped Opus by the way.
Isaac.
That's dynamic bitrate. This doesn't support. It just doesn't work. We tried it for a year.
It works. It works. It eats CPU, but it works, and it works well.
Yeah,
and you need to optimize it.
Thousands of calls running on a PSTN side and doing transcoding.
That's different.
Then it just doesn't work.
Yes.
Tsahi, taking a look at this from a slightly different perspective, when will the devices, mobile devices, render the issue of computational load for VP9, for example, to be relevant? So it seems like at some point these things all become so powerful that...
Never.
You don't think never?
Never. Look, I think it was 7 years ago. 7 years ago, I worked at Rad Vision doing video conferencing. We had this project of taking a Samsung display, 24 LCD display. 24 just came out with 1080p. It was brand new. And Samsung came to us and said, well, you know what? We're going to change the video conferencing market. We're going to build a device that it's going to cost about, I don't know, 20% of what video conferencing devices cost today. Because we're Samsung, we can do that, And we don't want you to take this personal display and add video conferencing to it. We had a camera on top, do all the hardware stuff, you do the software. So we went and looked for a chipset to do that. Like anybody else in the industry, we ended up going with a TI chip, the DM6467, if anyone knows. It was the best one on that point in time, and it does H.264 encoding and decoding. You go, you plug it in, it works great. A few months later, TI came out with the TI OMAP. The same chipset, or similar, for mobile. They left that market since then, but they had the TI OMAP 4. And then we took that chip and we said, OK, let's see if we can put H.264 with 720p encoding and decoding on the chip. If you took the high-end laptop at that time running the Intel dual or core or quad core or whatever, this is what was out at the time, and you tried to run H.264 on the device, 720p, that was 100% of the CPU, assuming you had 4 cores to run it. So we took this, stupid TI chip, TI OMAP, that's like nothing. You can't run anything on that device if you compare it to a laptop. You put hardware acceleration on, you run H.264, encoding, decoding, 720p, same as you do on that, beast of a laptop, 20% CPU load. And you get better performance in terms of what you see, the video quality. Hardware will always top software when it comes to running a video codec. And the thing is that what you actually run there is just crunching numbers. There is no smarts in it besides heuristics and brute force. And the acceleration runs the brute force, heuristics you do with software on top. So there are two areas that are hard with the codec. The first one is the DCT. Okay, something like a Fourier transform. You take an image, you map it into small blocks, macro blocks of 8 by 8, 4 by 4, these kinds of things. And then you need to do some processing to move it from one plane to another in order to compress. This process takes, CPU, and it's doing the same thing like gazillions of blocks a second. You need that in hardware acceleration. You can't do it in any other way. Now you need motion estimation. Okay, you've got all of these blocks, and you've got two video images. In order to get from this one to this one, something moved. I'm not going to encode all the image again. I'm going to only decode the changes. And if I'm going to encode the changes, and if my face moved, I need to, tell this block that I already encoded that it's now here, not here. So now I'm going to go block by block on the image and start finding the best block from the past image or 10 images back in time. And I can, look at these blocks. I can look at all of the blocks of all the image. It made sense doing that for VGA, but then you get 1080p or 4K, and you need the region to be a lot larger because the pixels are smaller. Okay, so it becomes a harder problem to achieve with software. So the problem grows exponentially while the hardware, the software doesn't. So you can never match. You need hardware acceleration to build a video codec. And I know VP8 runs and everything is fine, but it doesn't. Okay? So we've got an issue also with audio. And the issue with audio that it doesn't get the same care and attention that video gets today in WebRTC. So we are going to stay with this problem of codecs with WebRTC, the same as we had with voice over IP, of the question, which codec are we going to use, when are we going to use it, and if it's going to work for us or not. There is not going to be an easy answer for the next several years, and TokBox are going to be very happy about it, although their R&D is going to suffer from it. So with that, I'm opening for questions, although we had a few. Thank you.
So I moved in February. This is the best session I have attended so far.
Okay.
So,
thank you.
my question is, again, we are doing something in audio, as I told you. Video is not even on the horizon right now.
Mm-hmm.
So what is the best codec for audio today? Opus we have tried and we moved back to ISAC. Because we do a lot of PST in transcoding.
So here's the problem. Opus is great. It's going to cost you a lot in the backend, and it's going to eat a lot of CPU on the mobile device. That said, it is going to offer you the best voice quality possible.
It also eats a lot of bandwidth. If
No,
you
it's
have
not.
3G network,
You need to
dynamic
tune.
bitrate-
You need to tune it.
Okay.
Okay, there is a good session that is going to be recorded 2 days from now at the Cranky Geek event, where Fippo from Ndiet is going to talk about Fippo did a lot of investigations, black box investigations on people that actually implemented voice over IP, and what have they used.
Okay.
So we looked at WhatsApp, Facebook, Wire, Skype, and a few others. And from there, he's got like, if you use Opus, this is what this company is doing, this is what that company is doing. That one decided to use a different codec. This one changed the bit rate. This one changed the forgot how you even call it, with audio. The sampling rate, okay, different things that you do with the codec to optimize it to run better on mobile. And you can do the same things on Opus, you just need to know how to do them. Because it doesn't come ready out of the box today. Why? Nobody put the care and attention in there. Okay, so it's going to be hard work, but there are companies that succeeded in doing that.
Okay, thank you.
That's it.
So, one question. So why do you think there is no investment in having hardware acceleration programs? What would be the reason? If we see that it's for CPU.
So again, I went towards Serge LaChapelle and I told him, well, you know, from Google, I told him, you're Google, you've got Android, that's like 1 billion devices. Can't you just go and force all the chipset vendors to put these codecs inside? He said, they don't care about WebRTC. They don't care about what we need. What they care about is YouTube. This is why you see VP9 decoding in these chipsets, but you don't see encoding. Because the world today is where the decoders are. Okay, not where the encoders are. You do have encoding of AMR low band, narrow band, and wideband, and all of these stupid things because that's what goes over the phone network today in mobile devices. So this is what's supported in hardware acceleration. AAC is there because it's part of MPEG-4 and H.264 when you go to actually streaming videos. You don't see Opus there because Opus is, well, too new on one hand. And on the other hand, it's for voice over IP and nobody cares about voice over IP. Sorry, we're too small of an industry yet, still. So that's the reason I got. It seemed reasonable. Otherwise, I'd have the same question. Yes?
Could you talk a little about the chip manufacturers' interests and any large consumers, presumably companies like Facebook that aren't, like, you haven't talked about it?
Okay. So Facebook is easy. They know nothing about video. That would be the answer. They've been doing that for what, a year, 2 years now? That's nothing. Google started, I guess, 5 years ago when they acquired On2. So they know something about video coding, not only decoding. Okay? So because they know nothing about it, they don't have a stand. Also, you need to understand that for these 7 companies to band together and actually come with this kind of a press release, that was like science fiction. I wouldn't believe that they could come into a room and agree on such a thing. So now that there are 7, getting the 8th is easier than putting the first group. So I'm not even sure if Facebook wasn't, let's say, in the loop, but decided not to join in the first round. So it might be the case. Chipset vendors, well, they have several problems today. The first one is they don't make any money. None of them is. Okay, their revenue is also very small and very tight because of the Rockchip and the other Chinese and Taiwanese vendors that come up with their own stupid chipsets that are just as good. ARM was good for everyone, but it's also bad for everyone at the same time. And they don't understand the users at the end of the road either. If I'm a chipset manufacturer, the people that I see as my customers is Samsung and HTC, no one else. So if Samsung comes and says, we want you to add VP9, okay, I'll add that for you, that's fine. But if Google comes, that's like, that's so far in the food chain that I don't even understand what the words they are saying. I'm not speaking to them. It's a different language. I had a chance to speak with chipset vendors because I was in the software doing voice over IP, and so it's not mobile chipsets, it's other type of chipsets, and you see the different languages and dialects that these companies talk. It's not the same thing. We tried, for example, Intel came to us one day and said, we're going to go into the set-top box business. We're adding encoding capabilities into the chipset. Let's go build video conferencing for a set-top box. So we said, okay, we'll take your money and build it for you. They say, it's fine. We build the reference design. And then we go sell it to companies. Stupid me goes as a product manager to sell it in Korea. I go into a room, go to LG to show them the devices. We had one from Intel and one from TI running encoders. We go, we put it up, they play, they say, okay, does it work on Broadcom? I say, no, why? They said, this is not a set-top box chip. we need it to run on Broadcom. That was the answer. Okay, why? Because set-top boxes you build on top of a Broadcom chipset. You go to Broadcom website. All their chipsets only do decoding. Why? Well, you know, it's a set-top box. You don't need an encoder. It just plugs into the TV and shows you movies. Why do you need to encode stuff in a set-top box? It makes no sense. Okay? Now go tell a chipset vendor like Broadcom that has the whole industry. He's like, you know, I'm the market maker. Tell him to add encoding to a chip that has got this kind of a margin, and now it needs to add an encoder. Doesn't work. So we understood too late that it's not a market for us. It doesn't make sense in that market. Now today it's different because all the chipsets there are ARM chipsets, and you just take the mobile chip from a phone and you put it inside, and that mobile chip already has an encoder inside because it has a camera and need to be able to do selfies for people. So so you have a different use case that brings you the ability to encode on a set-top box or on a smart TV because you need to have the same chipset as you have on the phone, because then all the development costs you less and economies of scale, blah, 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 it makes more sense. Okay, but again, these companies build the chipset so you can do a selfie with a camera with 720p or 1080p or 4K video results for a teenager to be able to stream it to the cloud or send it to the cloud and store it there. That's it. There is no video conferencing use case in there. So why should I use it as a chipset vendor? What's the point?
So do Samsung or HTC have any interest in pushing them to change what they're doing?
HTC is not a company anymore. Okay, they probably have the best phones out there, but nobody is buying them. I need to buy a phone. I wouldn't buy an HTC phone because they are dying. Stupid decision to make, okay, but that's the decision I made. So they're not a player. Now the players you have on the market today are Samsung, maybe LG, okay. Then there's Lenovo or not, I'm not sure. That's Motorola today, and Apple. None of them really care about that. And all the rest don't care at all because they're like, you know, I take the phone, put Android inside, put a label, and sell it to the market, and who cares? So you've got this dissonance of what you need and what you actually get from them. So again, VP9 gets in there through the back door. Opus doesn't.
Like if you're talking about the mobile devices,
Mm-hmm.
iOS doesn't support WebRTC, and then all other Android vendors, if you buy an Android device, chances are good you have the Chrome browser, and use are not going to reinstall some other browsers, right?
That's a different story.
No.
I mean, it's a different story because you go into the question of, do I really care?
No.
Because, wait, if I'm an application developer and I'm leading you to the answer, I couldn't care less if the browser supports WebRTC or not. I can do whatever I want and I can implement whatever protocol I need. Even WebRTC I can put on an Apple device. Now the problem is, do I get hardware acceleration for the codecs that I need? The answer is no, so I need to do it by software. Okay? And then you see companies saying, well, I'm going to use WebRTC, but I'm going to switch the codec to H.264 because I can do hardware acceleration on the mobile device. And you see these kinds of decision making by some of these companies.
Okay. Let me ask you a different question.
Yes.
So if I'm a developer, application developer, and then I want to support only the mobile applications. So in such a case, because there is no support for the Safari or iOS devices, so is it fair to say for all practical purposes, if I support a Chrome browser, I will have good part of WebRTC users covered for mobile devices?
Well, I can't hear you that well from this far, but I think the following. If I'm a mobile developer, the first question that I need to ask myself is, okay, what languages am I going to use for this specific application? Is it going to be cross-platform development using HTML5? Maybe. It might be using Xamarin, and then it's C#, or it might be native all the way in each and every platform. I'm going to build my own whatever. Or I can use the new framework, a Facebook React platform. Okay? Almost in all of these options, I can use WebRTC. And most of the options will be in the part of the native applications, especially if I'm serious about what it is that I'm doing. And even with HTML5, you've got PhoneGap, and PhoneGap has plugins for WebRTC. Xamarin has companies that provide plugins for WebRTC. I think that you have both at TokBox, right? Maybe. I believe that you do. So you can do that. It doesn't really matter. The problem is if I'm coming to your website through the Safari browser, what is going to happen? Yes, that's a problem. But it's not a problem for application developers. And the world today belongs to the application developers, not to the browser. Yes?
What kind of like you keep speaking about these codecs as if like there's only one set of parameters for encoding them. Is there a possibility of like saying, well, I want to do a very small amount of encoding or a very light pass over the encoding and then I get a huge file size, or a very hard pass of the encoding, get a very small file size? Could I basically say, okay, my processor sucks, but I'm on Wi-Fi, so I can just do 30 megs per second.
So there, it never worked like that, and it never will, because usually if you have more bandwidth, you also have better CPU. Okay? But the issue is this. There are different mechanisms and techniques in which you can use to decode and encode video. There is, for example, SVC, Scalable Video Coding, where I can actually take and encode a stream, put it into layers, and each layer adds more, let's say, details to the previous one, and then I can decide which parts of it I'm going to send to whom in a conference. I can decide to use simulcast, where I encode more than once the same stream in different resolutions and play with it. Okay, there are different things and mechanisms that I can use. There are also single pass codecs, multi-pass codecs, these kinds of things. For real-time communications, it's only single pass codecs. You look at a bit once, you decide what to do with that bit, and you move on. You never go back to that bit. Why? Because you don't have time to deal with it. Okay, again, it's, let's say, 1080p. I think it's around 300 megabits per second that you need to process at the same time. So I'm not going to look at the bits twice. I don't have enough cache to do that. So all of the real-time codecs, it's single pass.
All right, but on a single pass, there's no such thing as like parameters, like I say, let's do minimal encoding.
Billion numbers of parameters. It works like this. The most basic part is you've got this DCT, the macro blocks. On each macro block, you can decide independently how much compression you want to do to that specific block. The more compression, the less quality you get. For example, okay, you can take, well, I'm going to do a lot more motion estimation or a lot less. This will again affect the quality of the video and the bit rate. When you build video codecs for real-time communication, you use a technique that is called the Leaky Bucket. What does it mean? It means, well, I want this stream to be 1 megabit per second. But you know what? Some of the time, I'm going to see a person that doesn't move at all and only his lips moving, or he's not doing anything. Or you can start fidgeting and move. Okay, so how exactly am I going to use 1 megabit when he moves or when nothing changes in the scene? It doesn't make sense. So what you use is a Leaky Bucket. You say, I have 1 megabit to invest in the next second. And then it needs to decide how much is left to change the quality of the video as it moves along. Okay, so a video encoder is art. There is no spec how you build that heuristics into the codec. You do it on your own, and each codec is different. Each encoder is different. All decoders are almost the same. Okay, and let's say the smarts is in the encoder. A few years ago, the most marketing that video conferencing companies did was, my codec is better. I can encode better with, I can do 720p in 1 megabit per second, and then Lifesize comes out and says, well, we can do 720p with 786 kilobit, which is less than 1 megabit. Our video is better. And you would see these wars between vendors, which simply stated they did a different type of an encoder. Now that said, nobody now builds encoders anymore because it's inside the browser. So you just tell it how much bitrate you have. It does everything for you, and you can complain as much as you want. That's what you have. So it's both good and bad. It's good because I couldn't care less about all of the encoder, the video engineers that I need to do that. In order to build that, they cost too much anyway. Okay? And it's bad because I have a lot less control of what happens with the video. I need to live with what I get. And it goes well with the fact that codecs are going to be free and open and no patents, because this is how you do it. Google, Microsoft, whoever placed that in the browser for me anyway, and that's it. I don't need to think about that. Did I answer your question, at least partially?
Partially, yeah. It basically sounds like you're saying that does not exist in modern video codecs. The ability to basically, like, let's say as a thought experiment, there was a codec that only encoded losslessly. So every single video stream is identical once you encoded this codec. And let's say there was a set of these codecs, right? Could I compare one codec to another and say, like, then I'd be comparing literally, the only thing left to compare is processing power and actual, how big is the file?
Yes.
You know?
Essentially, yes, you do these things today as well.
Okay.
You can do that even with lossy codecs.
Okay.
Because you encode, you decode, you compare, and you say, well, that's the difference from what I can achieve. And there's a theoretical limit of codecs that get implemented. Okay. Theoretical means if this is a stream, this is the spec, and I have all the time in the world and all the knowledge that I need, this is the best bit stream that I can get out of it, and then how close do I get to that theoretical limit? Okay, all of these things exist in, let's call it the video coding whatever, okay? But it doesn't matter in these areas. It's like at the end of the day, that's how you implement the codec, but nobody cares anymore. Okay, it's like the time that H.264 and VP8 came out, and people said, yeah, well, you know, H.264 is way better. And then you see these two screenshots of the same frame, and they circle here and say, you see, here they are better quality. And I look at it and say, well, it's, you know, the same. And my question was always, okay, show me a single video engineer that you show him 2 bit streams that were encoded, one with VP8, the other with H.264, and they will distinguish between them and say which one is which. It doesn't exist. You know, it's.
Yeah. But depending on your application, you could tweak the parameters differently. If you were so interested, you have a native app, and you're like, you know, my app is only for screen sharing.
Mm-hmm.
There's very different things you do for screen sharing than you do for a person speaking on.
Yes. So a good example is the guys at Screen Hero. The team that got acquired by Slack, they use WebRTC to build their screen sharing thing. They started with VP8. They said, well, it's trashy. It doesn't do anything for us good in screen sharing. That was about 3 or 4 years ago. And they said, we're going to replace that with H.264, use WebRTC just as the engine, and build a plugin for the browser. They did everything around that, and they have a great YouTube video about why they did that and what are the things that they need to implement and the mechanisms they need to implement in order to support screen sharing. Because this is screen sharing, okay? This is a slide. Okay, am I going to invest 1 megabit per second on this slide for the next 5 seconds, or 10, or 1 minute? Okay, but when I'm going to do this, I want the whole picture to change immediately. I don't need motion estimation. I just want the full frame to come in instead. And if I start moving the mouse, I just need the mouse, which is different than me, you know, standing here and moving my mouth and moving the head a bit and doing these things that video engineers do. And it's different than streaming the next, I don't know, what's the next movie that is coming out that is interesting?
Martial.
Okay, different than streaming Mission Impossible to streaming a Disney movie. It's a different encoder. Different parameters that you need to put in the encoder. So you won't use generic encoders for that. You will use encoder for a purpose, or you will hint to the encoder what it is that you are trying to achieve.
Is there a better codec just to do screen share?
It's not a better codec. It's a better encoder.
The parameters you put while
Yes.
encoding.
Yes. So for example, in the TV industry, when you encode, let's say, movies, not real-time stupid things that you see on TV, but movies, the encoders are offline encoders, and sometimes we have actual humans that manually give hints to the encoder along the way of what to do.
Oh, in real time, while encoding.
Not in real time. It's done offline. And then you got a stream, and then you get it to your TV. Okay, and for encoding for TV, for example, there are 3 types of frames, at least in H.264. There is an intra frame that has everything, a P frame that looks at one of the previous frames to encode, okay, to decode, and then there is a B frame, which looks at the future. Okay, but how you can predict the future? Well, you can if that's a movie that was recorded in advance. Because now I can use a future frame to decode a past frame because I've got everything buffered already. Okay, so you use different mechanisms of the same codec when you encode different types of content.
Data.
Yes.
Okay. Cool.
Yes.
I was thinking about the motivation for different companies to join an alliance. And what about Microsoft? What is the benefit there?
So, hard to say, but I would say this. Office runs on Android and on iPad. And Microsoft actually appeared today on stage, okay, with Apple. And Microsoft Edge is actually a browser that adheres to standards. And they've open sourced .NET recently. So this is not the same Microsoft that was 5 years ago or 10 years ago. That's one. And the second thing is this slide. I don't see Microsoft here. Okay, they have no vested interest in H.265. They're not a chipset vendor. They build operating systems. They build unified communications. Now, if you look at the unified communications in Microsoft, Skype won. It might be the code from Link, but Skype won. The branding now is Skype. Skype actually used VP8 until it got acquired by Microsoft, and then they switched back to H.264 because Microsoft needed them to switch back. But my guess is that, let's say, the strong team at Microsoft today is actually the Skype people doing the decision making.
So, in case of Microsoft build that the OS, every time they sell OS, are they paying that unit or is the hardware price? Is the hardware vendor who pays that 20 cents?
I'm clueless. I really don't know. And I'll tell you why. When we sold software that used codecs, we said, you know, we're not going to, you need to buy the royalties, the patents from someone else. It's not us, it's them. Who is them? I don't know. Okay, that was the real answer. Now, when the hardware business in our same company went and sold out an MCU or an endpoint, they actually needed to go and deal with that stupid things. So a chipset vendor, for example, Qualcomm would say, well, I don't know. It's not me. I'm not using it, you know. Implementation, it's not me. Okay? So
that could be the reason why Microsoft joined.
So probably the companies, no, the companies that pay, I think that it might, I don't know if it ends up being, for example, HTC or Google, for the phone to be able to use H.264 in the camera application. I don't know which one of them pays. Okay, it's tricky business because it's a business for lawyers. It's, for example,
is it not known in the market who pays?
I'll ask you this. Who exactly do you go pay for the H.264 codec?
I pay.
The people in the MPEG-LA group, right?
Yeah.
But at the end of the day, the company that went and sued HTC over VP8 was Nokia because of patents it had on H.264. And Nokia isn't part of MPEG-LA. Okay, so you never know who holds the patents and who you need to pay at the end of the day. Joining a patent pool is voluntary. Okay, the only thing that you need to do in order to have a patent in H.264 is to announce that you have a patent on H.264 and you're willing to give it reasonably priced. Okay, what's reasonably priced? It means that if I priced it $2 for you,
0.5%.
I can't ask 5 from him, and I can't say to him, I'm not going to sell you. I need to give you, the pricing needs to make sense. That's the only things that you need to do today with patents on codecs that are in the standard. Otherwise, the standard bodies will work hard to throw you out of the patent pool. For example, GIF was patented. Okay, a lot of years, companies, or let's say websites, moved from GIF to PNG. Why? Not because PNG was better, but because Philips, I think, decided to start asking money for their patent. Okay? I think it was them. So then one day, the guys in the standards that built GIF came out and said, well, this is the patent, this is the spec, let's move the spec, call it GIF 2000, I think, and ta-da! That's it, no patent anymore. So you see these kinds of games, and you need to know how to play the game when you patent stuff as well, and when you sell it. And one of the problems we had is, okay, now we've got G722.2. We're using that. We're fine paying, but who exactly do we need to pay and when? It's sometimes more than a single company. Each one have different rules. Like, up until 10,000 units, you don't need to pay anything. After that, you need to pay. There's a cap at this amount. Now, each company will put its own rules on its own patents. Okay,
so you have to pay to one company? Or you have
here only to one, only to MPEG-LA, but also to HEVC. And to another company that has a patent, but it's not in the pool. So it's complicated. Patents are complicated. Not having them make life a lot easier, even when you have the money and the willingness to pay. Okay, at Radvision, we had a person working almost full-time just to decide how much we need to pay each time to whom. Okay, full-time job. Just this stupid thing.
Yeah, but these guys are done anyways. As we move forward in those guys.
Assuming I'm correct, which might not be true. There is an alliance. It's, 1 week old now? Okay, give it time. We'll see, They might decide tomorrow that they don't like each other anymore.
Then there will be a third alliance.
I don't know. Yes?
Do you think these guys, who are obviously building the next video codec, are going to indemnify companies against...
Why should they?
Against...
No, none of them will.
But these guys are going to be very, very crafty and try and make money from the small players that take that codec, because they're losing money.
Yes, you can say that this is why Nokia ended up picking up on HTC and not on Google.
Yeah, exactly.
That's life. I don't know.
Encourage your kids to get a law degree.
No.
Very interesting.
Okay. Thank you all.